I think the best place for us to start is at the Big Bang. Some call it the beginning. Let's just call it a beginning for now. The Big Bang theory is the current prevailing model of the beginning of the universe. The current theory goes something like 13.6 billion years ago, there was a massive explosion, and from a point smaller than an atom, the entire universe sprang forth. Okay. Haramein's question for the prevailing model is simple to start, but has never adequately been addressed by modern physics. Based upon some of the most fundamental laws of physics, every action has an equal and opposite reaction. Matter, energy, can neither be created nor destroyed. The amount of energy that was generated in the Big Bang was clearly enormous. An entire universe worth of energy. Everything we see came from that singular moment. For all the atoms in the universe to have popped out of a point billions of times smaller than an atom, a force had to be present to push out that creation. Something had to be there to cause that to happen. The laws of physics insist that energy could simply not have sprung out of nothing. In Haramein's model, this force springs from the vacuum itself. It comes from the ether. Physics textbooks say a good way to imagine the way galaxies are moving apart from each other right now is to imagine pennies glued to the outside of a balloon. And as the balloon is blown up, the pennies move away from each other on the surface of the balloon. But notice in this analogy, balloons do not simply blow themselves up. Every action has an equal and opposite reaction. So where does the energy come from to blow up our universal balloon? It might surprise a lot of listeners to find out that modern physics does indeed document a source from which this energy could spring. But that source is largely ignored in our reckoning of universal dynamics. In Haramein's model, the energy to create what we perceive as matter came from the vacuum itself. It came from the ether. In quantum dynamics, the mathematics are dependent on an almost infinite amount of energy density in the vacuum itself. In order for quantum dynamics to work at all, it must be there. What do I mean when I say almost infinite? It's a funny story. Quantum theory, in its early years, was plagued by many calculations resulting in infinity. The physicists would call this result nonsensical, though there are plenty of good reasons to consider the implications of these results. Modern physics does not allow for an answer of infinity to be appropriate at present. Haramein has a different view. He believes that infinity can oftentimes be a sensible answer. We just have to look at that concept of infinity and ask, what does this mean? And in a later video, I'll get into that. But for this story, in the 1940s, a coalition of physicists and mathematicians would think of a clever way to do away with this uncomfortable infinity. In a process called renormalization, they used the speed of light as a constant to determine the smallest bit of energy possible. Then, using this number, you can determine a finite amount of energy that must exist in the vacuum itself. You do this by packing that smallest bit of energy as densely as you can into a cubic centimeter. And you say, okay, well, that's how much energy can exist in a finite way, because that's the smallest little packet that can exist. So when you do the math on this, though, you get something pretty shocking. They figured out that the finite number for the amount of energy that exists in the vacuum is 10 to the 94th grams per cubic centimeter. 10 to the 94th. That is a huge number. Staggeringly huge. Just massive. To get an idea of just how big this number is, think of the scale of the entire universe. In our galaxy, there are about 100 billion stars, and there are hundreds of billions of galaxies, many with far more stars than our own. So, let's do a little math. Think of the mass of our sun. our sun has over 300,000 times the mass of our Earth. So take the size of our Earth, multiply that times 300,000, and now multiply that number by 100 billion for the rough framework of the mass of our galaxy. Now multiply that number by 100 billion galaxies. So it's a big number, right? So all of the mass of everything that we've ever seen in the entire universe, if you compacted the entire universe worth of galaxies into 1 cubic centimeter, that cubic centimeter would have an energy density of 10 to the 55th grams. And there'd only be one of them. So 10 to the 55th compared to 10 to the 94th. So what we're talking about here is the energy of the entire universe being 40 orders of magnitude less than the amount of energy that I'm quite literally holding right now. Wow, that's a lot of energy, particularly because this isn't the only one. If you imagine how many cubic centimeters there are of that stuff in your house, imagine how many in the entire Earth. Imagine how many in the entire universe. That is a lot of energy. And if that's not infinity, it's certainly the closest thing that we've ever figured out to it. So Haramein's model states that the energy could have come from this infinite sea of energy called the vacuum. And in fact, it makes sense to believe that it did. The second law of thermodynamics states that everything should be grinding to a halt all around us. But on a grand scale, it doesn't seem to be matching our observation. In fact, the universe is expanding at an ever-increasing rate. It's accelerating. So wouldn't it make more sense to say that whatever happened during the Big Bang didn't just happen at the Big Bang? It started there. It continues to this day. There is no law of physics that just happens once and then never happens again. That's a pretty big, exception. All mechanisms in the entire universal working should be accounted for. And whatever caused the Big Bang should be present in some form still. It's just logic. A more logical viewpoint would say that the vacuum was disturbed out of equilibrium then, and energy continues to be transformed from the potential energy of the vacuum to the kinetic energy of matter to this day. So every galaxy is constantly creating more stuff. Every atom has a source of energy that keeps it spinning. In a later video, I'll get into the nuts and bolts of the mechanics of this interaction, as I know it's a really big concept in the beginning. But rest assured, there is a lot of absolutely brilliant logic to bear it out. A huge body of observational evidence, a comprehensive body of mathematics that describes this theory in a much more elegant fashion than the mathematics which describe the current model. And I'm going to describe all of that in tiny digestible morsels. So I'm very happy to answer questions that might arise, and of course the goal of these videos is to outline Haramein's theories. The best way to get the full description of the ideas I outline is to watch Nassim himself describe them. These videos are online. He has a comprehensive set of lectures on DVD. I've got those available to purchase. You can also order them through the Resonance Project website, www.theresonanceproject.org. I'll put it over in the little sidebar too. There are several elements which work together to describe how this amazing interaction occurs, and I'll get to them one by one. The next video will be on the dynamics of energy movement and how those dynamics play into this continuous creation theory.